been on the road now for nearly 8 months. So I thought we're gonna have a look at what electrical upgrade we did before taking off. And here it is. We chose to do the lithium-ion upgrade and upgraded to a Victron MultiPlus 3000 VA Inverter Charger. I think it's called a hybrid inverter as well. I have a couple of solar charge controllers which handles all the solar panels on the roof. We also have a smaller inverter which is a 230 volt one because we're in Europe. We got some protection, some fuses, and a shunt as well, and the lithium batteries obviously. So I chose to do all this installation myself, and I think you can. I didn't have any prior experience with 12 volt systems, but I did find a really good local supplier that could help me pick up all the parts I needed and then also helped me through the process. Then, like, I chose to go all Victron stuff, and they have a really good community where you can post questions, and it's a large community and really helpful. So they helped me draw out all the schematics along with Eltric, which I bought all the gear from. I did record everything when I did this back in 2019. So I thought we can have a look at how this installation went back in 2019. So finally, all my Victron gear has arrived. I've ordered everything through Eltric in Uppsala. Pretty excited to see what has arrived. This is actually the project that I was meant to do from the start. Not all this water damage renovation and all that. The only thing I planned on doing this RV really was this electrical thing. Now I've obviously ended up spending hours and days on this whole bedroom renovation, which has turned out quite good. But I'm looking forward to this particular upgrade, and I've done some serious shopping for this and might have been going overboard a little bit, but I think it's time for me to join the Victron cult. I've gone all in Victron gear. I got color control, I got 2 inverters, I got the lithium batteries. So the whole plan here is to upgrade to lithium batteries. Today I have lead acid batteries, so upgrading to lithium obviously involves a few new bits and pieces. So a quick rundown of what I got. This RV is imported from the US in 2014. And obviously the US is their electrical grid is 120 volts at 60 Hz, I believe. And here in Europe we are having 230 volts on 50 Hz. So what the previous owner did to this RV was install a transformer which converts the 230 volts into 120 volts 60 Hz, which then feeds into the old inverter in this RV, and that inverter then feeds the power to charge the batteries and to all the plugs in the RV. Now this RV also has a generator which also is 120 volt, and I got 2 roof ACs, I got a water heater, everything is running on 120 volts in this vehicle. So I've also decided not to change that. So for this project, I've bought a new MultiPlus 120 volt inverter. That's gonna replace the old Inverter Charger. The reason why I'm switching out the old Inverter Charger is, first of all, it's not a pure sine wave inverter, and I have no idea how to program that thing to work with lithium batteries, which I really want. So I found a good local supplier that helped me a lot choosing what I need and how to connect it, and I got their support during this build, which I think is really important, because I've realized there's quite a lot of things you need to consider when using lithium batteries. So I got a new inverter charger that's gonna take care of the charging for the lithium batteries. I also got a DC-DC buck boost, which is gonna work as the charger for the from the generator. But I'm hoping I'm gonna go into details about all the components and how I install them. So yeah, hopefully we get a good run here. So this is all the electrical stuff on the vehicle. This is the inverter charger that I'm going to replace. I'm going to remove that today. This is the solar charge controller. I'm also going to remove that and disconnect the solar panels. And this actually seems to be have come off. This is probably for the solar panel. They pretty much didn't give us anything, I reckon. I'm gonna remove this bit here and see how this is all wired up. And I'm gonna mark and label everything so I know how to get it back if I need to. I'm also gonna look into a way of covering this floor here and the wall with this aluminum bit I got here. Here is where the battery is gonna go, the new ones, so I'm gonna remove these. So we'll see where we end up.
The old inverter is a 1500 watt modified sine wave inverter charger. As many of you know, the modified sine wave isn't really good for charging laptops and other fine electronics. Also, we're doing the change to lithium batteries, and this inverter can't really handle the charging. I wanted this compartment to look good, so I decided to cover this area with aluminum mesh.
So let's start with the batteries. This is gonna be a quick unboxing. I've already taken these out once before. So I decided to go with Victron's lithium batteries. I got two of these, 200 amp hours, 12 volts batteries, which I think are gonna work fine. One advantage with using Victron's batteries is that I'm gonna be able to, if I want to, I can add a third battery later on down the line. And it will still work as long as I fully charge them and balance them. They should be fine to add a third battery later on, which I really want, but these are not cheap, so I started off with two. So we'll see how how far we get with 2 batteries. Now, to be able to charge the lithium batteries, I bought a new inverter, the MultiPlus 12 volt 3000 VA 120 amp inverter charger, 120 volt one. So this is going to replace the old inverter charger, which is the old one is 1500 watt modified sine wave inverter. So this is going to replace. This is going to be obviously a little bit more powerful, but most important, it's going to take care of my lithium batteries. I'm also going to connect this to the color controller, so I get a good visibility on what's going on. This needs to be connected to the computer, and I need to program this to be able to handle the lithium batteries. I'm also going to use this to initially charge the batteries, which is going to be done with a lower amperage. So I'm going to set that up. Fun stuff. I decided to buy a second inverter for 230 volts. We just want to be able to have some sort of 230 volts in our vehicle. So I bought this Phoenix inverter. It's just 1600 VA, but which is gonna work fine. I'm gonna install this and just wire up 2, maybe 3 plugs in the RV. I bought the Phoenix Smart inverter because this can talk to the color controller, because I want to be able to start and stop this inside the RV. Let's have a look at that. It's actually quite big. Tight fit in the compartment. I'm intending to install all this, but hopefully we'll figure it out. From this, I'm gonna wire the 230 volts to the fuse box and then into the RV. So that's for the 230 volts. For the monitoring of everything, I bought a color control. So with this, I'm gonna be able to see how many amperage I'm bringing in from the solar, from the generator, or from shore power. See the battery status. I think there's this feature here that so I can install and monitor my tank levels. But we'll see how far we get with that. And for this to work, I need a shunt and a battery monitoring kit. So I bought this, and I also bought the case for this. So this is all gonna look nice when I install it in the RV. This shunt, will obviously measure all the current going in and out of the batteries, which is really important if you want to know the status of your batteries. Down you go. Now, this box here is gonna be for the 230 volts, and I'm gonna install this circuit breaker combined with an earth breaker, I think it's called in English. I don't know, but it's a breaker. Let's call it a breaker.
So everything in this RV is built for 120 volts, but it was important for us that we could access 230 volts, and to do this we chose to go with the Phoenix Smart inverter. This particular inverter is the smallest in their series. It's only 1600 VA, but so far it's been plenty for us. we use the color controller. To connect this Phoenix inverter, we use the VE Direct communications port. I chose to buy a VE Direct to USB cable, and then I run an USB extension cable all the way through the RV and up to the color control. This gives us the ability to control the Phoenix inverter from the color controller, which has worked great. For the main inverter, we went with the MultiPlus Inverter Charger, 3 kilowatts or 3000 VA, which is gonna be plenty for us to run the water heater, microwave, our TVs, and all the odds bits and pieces like computers or whatnot we are now charging. This is a hybrid inverter, which means it has the capacity to boost grid power, which has really come in handy. We're now been living with this for 8 months, and here in Europe we usually get like 10 amps from our grid power, and this feature comes really handy as you can cap the incoming grid power. You can set it at 10 amps, and then if you temporarily use more, the inverter charger will actually draw power from the batteries. So on the DC side, this MultiPlus wants 2 battery cables, 50 millimeters. On the negative side, I go through the bus bar, and on the positive side, I ran it up to a cutoff switch and then straight to the batteries. Now, so this inverter doesn't drain the batteries. I use a VE Direct to BMS connection, which I can connect to my battery's BMS. So in case of a low voltage, the inverter charger will shut off and only charge the batteries. And in case of an over temperature or any other faults with the batteries, the inverter will shut itself off. Now on the AC side, this inverter is similarly set up as my old one. It has a AC input and 2 AC outputs. One AC output is for the inverted outlets in the RV and goes through a separate fuse box, and then my second line out is for when connected to shore power or when you're running the generator.
So for the solar charger, I went with SmartSolar's MPPT chargers, also from Victron. I chose 2 of them because I had originally 2 panels on the roof, which I still don't know what brand it is and what they are rated for. So I thought I'll buy 2 and connect the 2 old ones to one charge controller, and the 2 new panels I ordered to the other controller. Turned out they actually are pretty much the same, so I at some point can, if I want, just connect all 4 panels to one of the solar charge controllers. But having 2 gives us the advantage that half the vehicle can be shaded and we'll still getting power from 2 panels. Installing these was pretty straightforward. I use 6mm wires coming from the solar panels in through a 30 amp fuse. These fuses also works as cutoff switches if I ever need to do some service on them, as you're supposed to cut the PV power before disconnecting the solar charge controllers from the batteries. And for these solar charge controllers to be able to talk to my color controller, I used the two VE direct ports and had a VE direct cable, which is 10 meters, one for each controller, which I ran all the way through the RV up to the color controller. From the solar charge controllers, I ran as a big a wire as I could fit, which in this case were 10mm wires. And before going to the battery bank, I mounted these on a BatteryProtect, which I actually don't have any video on, but I'll show it here. So it's mounted onto this BatteryProtect, which is a 100 amp Victron BatteryProtect. And in this case, I actually mounted this in reverse to be able to handle the charging. I also mounted my DC-DC buck boost through these BatteryProtect. Then I ran the wires up to a cutoff switch and then directly to the battery bank.
So now to the battery compartment. This compartment didn't end up as neat as the compartment for the inverters. That's mostly due to that I wanted to reuse all the cables from the last installation. As I was doing this installation, I quickly realized that cables wasn't that cheap to buy, and I needed a lot of it. So this didn't turn out as neat, but I'm still pretty happy with the results, as you will see. But I can run through the components. I use one cutoff switch for the inverter, the big one, the MultiPlus. Then I use another cutoff switch for all other DC loads, including my Phoenix inverter. And then I use a third cutoff switch for all the charging from the solar panels and from the DC-DC buck boost. On the DC distribution side, I use a BatteryProtect 100 amps. And on the charging side, I use a similar BatteryProtect, but it's mounted in reverse, so it works for charging. I also have a BMS to my batteries, which are two batteries, 200 amp hours each, which is connected to the BMS. And for the charging, I use a DC-DC buck boost. It's a 50 amp charger, which takes power from my starter batteries and feed it to the house bank.
So now, with all that done, this is how it looks when we actually use it. So we chose to install the color controller next to our other electrical panel, where we can switch on and off the water heater and check our tanks level and the water pump and all that. And here we got the color controller. It's in focus now, and that shows us the current status of the battery, how much DC power we're drawing, how much PV power we're getting. It's quite late in the afternoon now, so the sun is about to set, so it's not much. This up here is the AC loads. That's pretty much what the inverter itself is drawing, 13 watts, alongside with the standby on our televisions. Up in the left top corner here is where the grid power is showing if we're connected to shore power. It allows us to pretty much use everything, even though we're just connected to like a 10 amp fuse, which has been super useful. This one here pretty much shows the same thing. That's our battery status. This is actually with the current draw, we can will last for 64 hours.
and the voltage, and that's the starter batteries and how much we're drawing. So that's how it looks. I'm pretty happy with the installation, and we have really used it. So that's it. That's all the electrical upgrades we have done. This has really made it possible for us to stay on sites where there is no power for extended periods of time, which has been really nice. And from here, I guess you can always upgrade. In our case, we would like at some point to add maybe more solar, or at least make the solar panels tiltable. In our case, like, we can use a lot more energy than we do. We can always run the water heater or the fridge on AC power instead of LPG. But with the current battery bank, 400 amps and 700 watts of solar, that really can keep us going for weeks without plugged in power, which has been great. So that's it for now, and see you next time.